Yeah, the only people I've seen that actually use Microsoft Teams are AstraZeneca.
Mm.
So yeah, their corporate loved Teams for whatever weird reason. We
Hmm.
found it so clunky and just difficult to work with, but
That's fine. Yeah. Okay. So, as we are just waiting for people to trickle in, I would like to check in with you guys and just see how you're feeling after the week. It's okay if it felt not fun. You can share that as well.
Adina shared a screenshot of something that she was encountering this morning.
Yeah.
And
Do
yeah,
you want
Adina,
me?
go jump in, Adina.
Okay. I mean, I was starting to download Conda. I was working with Alicia a little bit on it, so we got like we started copying and pasting in the like the text from the slides.
Hmm.
So we got to the third line, but after that, I don't think we got farther than that. So yeah.
Yeah, so both Adina and I, we were able to download the file, like the mini forge file,
Hmm.
and then we were able to use terminal on because we both have Macs to like run it, and we were also able to create and activate the Daisy environment. But then once we, I guess, uploaded or tried to run Python, like the 3.12.11, it gave us an error and it said that that file didn't exist or something like that. So we're not sure what to do after that because we have the environment. It's just like the Python file isn't like
Hmm.
getting located or something like that. And maybe it's the version. I'm not entirely sure though.
It's useful for me if you can send the exact command that you tried to run with
Mhm.
the exact error message that you got.
Okay. Should I like share my screen or like put it in the chat or whatever's
Um,
helpful?
yeah, would you go ahead and share your screen?
Yeah, absolutely. I'm not allowed to share my screen,
Mm,
like
I
setting
wonder if
wise.
I'm allowed to. I'm
Like maybe
also
you could
not
change the
allowed
setting.
to. So these
I think it's
are,
the host, so
yeah, so Nori is the host of this
Nori.
meeting. So Nori, if you could make me a co-host. In the meantime, you can send it in the chat. That way we can keep
Okay.
moving the meeting forward. Um, mm. Ah, I see. So with the command that you ran, you put, I see you just directly copy and pasted what was on the PowerPoint slide, but we don't actually want to have the parentheses around that. We would
Okay,
just say
so just
conda
remove the
install.
parentheses.
Yeah, but I think it might need two equal signs. I'm double checking right now.
Okay. I also updated this slide because Eddie and I got an error when we were activating the environment. There
Hmm.
wasn't quotations around Daisy environment, Daisy
Hmm.
underscore N. So I just put quotations around that as well.
When you're activating the environment, you shouldn't have to have the quotations around it, but you did
Um, it gave
on.
us an it gave us an error message without them, so I just put them in there. I mean, you can always remove it as well.
I'm just wondering what was causing the issue. Okay, yes, so one equal
Uh,
sign should be sufficient.
Sorry, Emily. Everyone now is a co-host, so everyone should be able to share their screen and just to facilitate that in the meantime.
Thank you. Okay. So I just sent the commands in the chat, but yeah, it should be one equal sign and without the parentheses. That was still there because before I just
Okay.
had in parentheses the specific version and I didn't
Yeah,
update the
got it.
PowerPoint.
It is running for me, and I'm just downloading Python right now. But it says downloading and extracting packages, so it is working. Thank you.
Awesome. Yep. And then, so for really quickly, the screenshot that, where is it? That Adina sent. Let me share my screen so that we're all looking at the same thing. I'm just
I
gonna
actually
share my
don't think that
whole
was helpful because that was, I guess, like the I forgot what it's called, but the file that it downloaded, the mini forge that I downloaded.
Mhm.
But then I opened it in terminal.
Okay, yeah. So with the where is it? So this is the link from here for downloading Conda. You download basically this bash file that you have, and then you have to run it. It gives you this bash script, and you know it's a bash script by the .sh. And so here we see the name of the file, the version of miniforge.sh, and from your terminal, you need to run the script. And then that should automatically have then Conda loaded. But Adina, you said you were working with Alicia to install Conda. So did you get past this step?
I was able to. Can I share my screen? Actually,
Yeah, let me stop sharing.
Adina,
okay.
I think if you run the code that Emily put in the chat, then it should work because we were at the same spot, like in terms of the file attribute thing not working.
If I put, okay.
So just put in the conda install python 3.12.11 into your terminal, and then it should run. Also, Emily, is there anything else we need to do after that, or can I just close my terminal application now?
You could close your terminal application now. So Conda is a command line tool that allows us to more easily install packages. So Conda is a package manager. I use it in place of pip. You might also use pip, but Conda is nice because you can have multiple versions of this, like Python 2 and Python 3.12.11 could be downloaded at the same time. And you can specify when you're using different versions of the tools by specifying using different environments. So that's why we have Conda activate DaisyN, because we want to use the environment specifically for this internship. Okay, Adina, were you able to, did you want to share your screen, or are you trying the Conda run or
Yeah,
Conda install command?
I just tried the Conda run, but I'll share it now because I don't know what to do next. So,
And for Yaya, who just joined, we're just going over Conda installs and Python installs right now.
All right, thank you.
sorry.
Do we still want to share screens? Did her internet freeze? Okay. I think her internet is frozen. So yes. Kalyani, Amika, and Yaya, were you guys able to download?
Adina briefly dropped out. Her internet connection just dropped out for a second. She's back in.
Yeah, I see she's back in now. But
Oh.
was it?
Well, I had to quit Google Chrome to like update something, but I'm not able to share anymore.
It's okay, I can handle this. I will try to make you a co-host so that you have permission. Am I able to make you a co-host? I will just change the share settings. I'm not able to make you a co-host.
Would Nori have to do it?
You should be able
Possibly.
to share now, Adina. It took a second for the co-host permission to be sent to you, but you're listed as a co-host again.
Okay. It's saying disabled share.
I don't see that she's a co-host when I look at the participant list.
Okay, I'm gonna revoke the co-host permission for a second then. And oh, it's because it's old Adina was the co-host, not new Adina.
Am I doubled in here?
Yes, there's two versions of you right now, and I had the other one as the co-host. So there you are. You
Oh
should
wait,
now
can
be
we
able to
like kick
share.
the other one?
Let me see. We'll just make both of you right now co-hosts so that you can get permission to share. There we
Okay,
go.
can you see it now?
Yes, yes, yes,
Okay,
yes.
so this is what I have. After I put in that last line that you put in the chat.
So what I see here is that you're in this DAISY environment and that the download was successful. So
Okay.
that means that you don't get an error message. So everything happened as it's supposed to, and then that's good. There's nothing else to do.
Oh, so I can just like close this out. And okay. So where would I find like what we're supposed to be using? Like the app that we're supposed to be
VS
using?
Code?
Yes.
So in the PowerPoint, there's also a link for downloading VS Code.
Okay.
Yeah, Alicia.
Just speaking of VS Code, I just downloaded the application, and am I supposed to sign in with my Google account, or like, do you want us to sign in right now, or do you want us to wait?
I mean, it just depends on your preferences. I
Okay,
don't think
so
I'm
we can
signed
just
in
sign
on
in.
my VS Code. Yeah.
Okay, sounds good. Because there's also an option to like sign in with like GitHub, and I think it's like linking my account. So I'm just gonna go ahead and do that.
Yeah, it can be good to do that, but that is going to be just more advanced than what we're going to go over generally. But if you're using GitHub, it's more convenient to have VS Code linked to your GitHub. So, did anybody else have any issues with installing Conda or Python? I take this quietness to mean that you had no issues.
So, so I think that most people ran into at least one or two errors when getting the script started. So I think that what everyone is most excited about is watching you do it in real time, just to see how the entire process flows.
Yeah, so I'm not actually going to be installing Conda in real time or Python in real time because I already have those on my computer. And I'm not going to uninstall and reinstall them. But what I will do in real time is follow the instructions for connecting VS Code to activate a Conda environment in VS Code. But everybody has to have all these things already downloaded before this can be helpful. But if nobody else is saying anything, then I'm assuming that this means that you already have these programs installed on your computer. Yeah, if that's not true, go ahead and say what the problem is so we can figure out how to solve it.
Also, if anyone needs help, like doing the downloading stuff for like Honda and all that, I can definitely help because I did like have to go through all that as well. So if anyone needs help troubleshooting that on a Mac specifically, I don't know about Windows or other computers, but on a Mac I can definitely help.
I'm trying to download the VS Code now, and it says that you can't copy the item Visual Studio Code because its name is too long or includes too many characters that are invalid. Like, can I share my screen again?
Sure.
Okay. Okay, so this is what showed up. Yeah.
Okay, so it's
Adina, I think it just copied. It said copying Visual Studio
right.
Code.
Okay,
So
and
maybe
so
go to File Home, check
would I just open
applications.
it here?
That's what it looks like.
Yeah.
Oh, like it's already open. Wait, so if I go to, is it in my, like it was moving it to my applications?
That's what it looked like, yeah. I would just search the app and see if you're able to open it.
Is it gonna be VS?
Probably VS Code. So is the thing on your desktop the small thing that you have here on that's already open?
This? I guess so, yeah.
Okay, what
It's just
happens
going
if
straight
you
to here.
click the Visual Studio, like click to open the Visual Studio Code icon? Are you able to do that?
Okay. And this is it, right?
Mm-hmm.
And I could just continue without signing in, is what you were saying?
Exactly. Yeah, I'm fairly certain I'm not signed in on mine. I highly
Okay.
recommend a dark backgrounds just so that your eyes are okay. Yep.
Okay.
Then you can also stop sharing. So you've got it all set up so far. And what we'll go through together is connecting the Python environment and Conda to the VS Code application. But first, again, I just want to make sure that we all have Conda and Python installed. If you have any problems, can you please unmute? Otherwise, I don't know about them.
I checked in with everyone else, and everyone else seems to have had the Visual Studio Code up and running.
Okay, then if we're all checking in with each other, can we use our shared chat either in the Zoom call or in the WhatsApp just so that we're all on the same page about what's going on? Because otherwise I'm out of the loop and I don't know what problems you guys are having, and I also don't know if you've already solved the problems. Just so that I can be in the loop with the communications, that would be very nice.
Guys,
Then
don't be shy about using the chat, okay?
I'm going to share my screen, and it is a little bit slow. Okay, so this is Visual Studio Code. Visual Studio Code is called a GUI or a graphical user interface. This is just the user face that I recommend for accessing coding documents. This works for Bash scripts. This works for Python and Jupyter Notebooks. This works for in our Studio documents. This can be connected with something you're running locally, which is what we'll be doing for this internship. But you can also use Visual Studio Code if you're using a virtual, like high throughput computing resources or a server. So it's very versatile, and you should be able to use it for everything you would need. It's easier than just accessing things in the command line, and it's also free. And there are other tools that are really popular. So Spider is another one that is popular because it's free for students. But as soon as you're not a student, it wouldn't be free to you anymore. So Visual Studio Code is the most common thing that people are using in industry, and it's most people that I work with, because they're not students, are also using VS Code. So this is why I want us to learn this. And you can see my color background's probably just a little bit different from yours, but just to give you some ideas of like what all these things are, here I have these tabs so I can see like different documents that I have open, and then open this specific file is a Jupyter notebook. So this would be similar to the Google Colab notebook, where you can see I have blocks of code, and then I have some blocks with text, and I can run those. If I click here, this will allow me to open a specific file on my desktop. And so I could, for example, go to my desktop, go to TUM, which is the university I work for now, and open this folder. Doing this when I'm coding will allow me to just more easily see different files that I have access to, as well as the path to those files. And I can copy those paths easily into like a document that I'm working in. I can also search for things within a file, but I don't have any open. This is not something we're really going to be talking about, but this is related to changes like in GitHub. So if I'm working on a GitHub repository, I can commit those changes and I can see kind of where I currently am in relation to past changes. VS Code has a debugging tool, which is really powerful, but this is more for, I would say, software development, or like if you're building a command line tool, which is also not what we'll be doing as part of this internship, but it's good that these things exist. They have a lot of extensions because VS Code is open source. People build a lot of tools with it. So for example, like the Jupyter Notebook things I already have installed, but I also have installed some things for remote connecting to a server, which is something I do for work. I also have some things installed for running R documents in VS Code and this sort of thing. This is for remotely connecting to a server. So you can do it really easily just with this tool, but we're going to be running things locally, so we're not going to worry about that. And then here I can look up Python specific things. So I can look at, here we have the environment managers. So we have Conda for managing our Python environments, but here there's information about the global Python environment. There's information about a virtual environment. And there's other tools like pip and poetry for running different tools within Python. So if you go into your VS Code, if you click on, so first see if you have this Python thing at the bottom, because this might be something you have to install as an extension.
I don't have that on my end.
Okay, then you'll go to the building blocks for extensions, and which one is this? If you search Python, this is just the one that's titled Python, and maybe also Python environments. Okay, has anyone been able to successfully install the extension?
Yeah, I was able to install it, and it automatically, when I did Python, it automatically also installed Python debugger and Python environments.
Okay, perfect.
So I guess they all come together.
Do you see the
Yeah.
okay, Python icon on the extension? That's great.
Yes.
So just as a repeat for everyone, we're going to these building blocks from the left-hand toolbar, clicking on extensions, typing in Python, downloading this Python extension, and it automatically downloaded the Python debugger and Python environments. So then we go to the Python icon. And I want you to see if you have a Conda drop-down menu here.
I have all those things, and also when I click on named, I do see the Daisy environment that we downloaded, and it says it's version 3.12.11, which is what we downloaded.
Okay, that's fantastic. If you click this check mark, which would be setting a project environment, you might have to have a folder open, I'm not sure. So you might need to go to the File Explorer and then select to open a folder. And I would actually make a new one. Next week, we'll start working with the data files and everything, working within VS Code. I just wanted to make sure that everything was installed before we start working with it. That way, it hopefully spreads apart the tasks. Okay. So, are you able to open a project folder or create a folder? If you click the file icon, it should say open a repository or something like this. And then if you go back, okay. Python is still downloading. Okay. Yeah, that's the only bad thing about Conda is sometimes it just takes a really long time for no apparent reason. But it's free, so it's generally quite nice. So then once you go into the Python extension from the left-hand toolbar, if you go down into named, you should see a named environment called Daisy Bio. I just haven't created this environment for my computer, my home computer yet, but I have another Python environment that is called py3_vs, which is short for Python 3 for VS Code. And you should be able to activate this. I get an error message, which is that no Python is found in the conda environment. And I think this has to do with the specific way that I installed conda on this computer. But if you click on it, you should see the Daisy environment, and it should be set as the environment for the folders that you've opened. Can anyone confirm if this worked for them?
I have a good question.
Mhm.
So I made a folder called Daisy Bio, like you did, and then I just went back to Python. It said to it asked me to trust the folder when I made it.
Mm-hmm.
I just clicked yes on that, and then I set the Daisy environment again.
Mm-hmm.
And now, like what I see, it says Python projects, it says Daisy Bio, my folder, and then underneath it, it says Daisy environment. Is that what it's supposed to look like?
Exactly. Yeah,
Okay,
that's
perfect.
perfect. So
Thank
for
you.
example, mine says base. It just means it's using my base environment, which is Python 3.12.8. But yours would say, or would hopefully say, Daisy environment, which means that it's using this conda environment that you've created.
Okay, so my Python just installed. Could you go back over what we did afterwards?
Mm-hmm. So your Python is installed in the conda environment. So now we want to basically open or point your project folder to that conda environment. So first in VS Code, you click these building blocks and then type Python.
I did that part.
Okay, and were you able to install these extensions?
Yes, I believe all three of them. Yeah, the debugger and the environment also installed.
Perfect. Then if you click the file icon, it should have like open a project folder or open a repository or something as the icon, and you click that. And
Like open
then
folder.
exactly, and then just make a new folder for the internship called Daisy Bio or something. So here I have one, but I opened the parent folder too. You can open it just as Daisy Bio.
Okay, I think I have it open.
So then once you have this folder created, click the Python icon in the left-hand toolbar, and you want to look actually on the bottom where it says Environment Managers. We want to see Conda here because we want to use our Conda environment for this Python version. And we're not using our base environment. We want to use a named environment. So you should have a named environment called Daisy Bio.
So for some reason, I don't see the Python icon anymore, but I did see it after it downloaded. But after I moved to the files, I don't see it again.
Did the entire toolbar disappear? Or
No.
would you try closing and reopening VS Code? Because sometimes
Okay.
when you install extensions, it has to reopen for the effect to go into effect.
Okay, I see it again. But, well, okay. I think the Daisy folder closed.
Then you can reopen it.
Okay. Okay. So when I open my Daisy folder, it looks like the Python closed again.
Do you want to
The
share your
Python
screen?
icon. Yeah.
Athena, that might be because you're in restricted mode, so you're gonna have to like trust the folder that you created. And it
Okay.
should be like in the bottom left corner, I think. Maybe I could be wrong. Yeah, you're restricted mode right now.
Do you see it?
So
Like the
go to manage at the top
top.
where it says restricted.
Oh, I
Yeah,
see it.
just click on manage.
Okay.
And then just click trust. And you should be able to close out of it. And you can see Python on your left now.
Okay, I
Good
see it.
catch, Alicia.
And then, okay, I'll stop sharing.
Okay. So has everyone been able to get to this step? Again, we start using this on Monday. I just want to be sure that it's already set up on everyone's computers on Monday. Okay, I see one thumbs up. I'll share my screen again. I see a second thumbs up. Okay. So you should see the folder that you've created and the content environment that you've created. I just haven't created the same one on this. Okay, I see a third thumbs up. That's awesome. So on Monday, I'll have it set up so that the names of mine match the name of yours. Just it'll be less confusing that way. And then if we go back, just to give you an idea of what this looks like, this this will show you folders in, I think, kind of the conventional way that we see them, but I'm able to access files really easily. And then I can also add text here really easily. README file. I don't want to generate code. And then I have to manually save the file. So on my computer, I press Control S. You with Macs would press Command S. And then, yeah, it just saves the file. So once we open our Jupyter notebook file, the file opens in here in the same way that the Google Colab files open. So it's just, instead of accessing the internet to use Python, we can access it locally on our own computers. So within Python, sometimes there are modules. Let's see if I can open a recent file just to show you an example. So here's just a brief example of something I did at work. Yeah, Alicia.
So you said that Google Colab would like work similarly here on VS Code. Can we like can the Colab stuff into like VS Code and just start coding in VS?
Absolutely. You would just download the file instead of making
Okay.
a copy. Yeah.
Okay, perfect. Thank you.
And then so this is just a Jupyter notebook file. Typically you have all of these modules listed at the top because I need to import them if I want to use tools from these packages. And you can install these with Conda. So this is why we're having a unique content environment created on the front end. It'll just make using any special tools easier on the back end. Alicia, your Zoom hand is still raised. Do you have another question or do we just wait? Okay. Then, yeah, this will become more obvious next week, but we've done the hard part now, which is just setting it up. So now we can transition back into just talking about pandas in Python. So let's see. It might be good if we first talk about the coding modules. So in this folder from our rubric, there's this folder htpda copy. If I open that, there's now this htpda solutions. If I go into it, this is the module 1 solution sheet. It seemed like in general, this was not fun to complete for people. Is this a fair assessment? Yeah, I mean, this makes sense. Coding is hard anytime you learn it, and you have to learn by making mistakes, which is a very frustrating way to learn, I think, generally. And this is also, you're learning to code in the context of biology. So it makes it a little bit more complicated than if you were just learning to code. So for the first part, we get these lists with numbers and certain proteins that we're interested in. And the question here is to save this information from samples 1 to 3, as well as the proteins, then print the data type, and then compare the first elements of sample 3 with the first element of sample 4 to see if they are identical. So we can store these just by, oops, and this is my cat Seamus saying hello. So we can store these just by saving them in a list. So the only difference from what was in the prompt was that the brackets are added to indicate to Python that this is a list. Another way that you could have done this is by writing out list and having the curly brackets. This would have been the same. And then similarly here, so all of these things are all lists. And then if we actually, here we're checking the type of an individual item in the list. And then here we're doing an evaluation to see if the value of the first item in sample 3 is the same as the value in the first item of sample 4. Okay, it didn't like that I did it like that. And then we're seeing if the data type is the same. So we see that the first item of sample 1, which is 5.82, is a float. The first item of sample 4 list is 9, and this is read as an integer. And then the first item of the proteins list is a string, which is expected. And then if it's checking to see if sample type 3 is the value is equal to sample type 4. That should be false. Or no, that would be true. So floats and integers can be read as the same because they're numbers. But that is a type that is not. Okay, I am surprised. Compare the first element. Are they identical? What is the data type of the comparison's return value? Yeah, so the data type that it returns, because we're doing an evaluation, which is done by 2 equal signs, regardless of whether it's true or false, it's returning a Boolean, because both Booleans are true and false. Yeah. Was this one challenging for people, or do we have questions about like why we're setting it as a list? Go ahead.
I did sample 3, like the first element of sample 3 equal to sample 4, like the first element of sample 4. I got false. I
Yes.
didn't print it like that, but why would it be true? Because aren't they technically? I thought we were comparing like the data types and not those.
So this I do expect this to be false, so I expect this to be something weird in the way that I have this set up, because if we look at the literal value 5.82 and 9.0, or excuse me, 9. Oh, this is sample 3, not sample 1. That's why. So 9 is equal to 9.00 because numerically these are the same values. So if you have the exact same value, Python doesn't care if it's an integer or a float because mathematically they're evaluated the same. If I were to compare 9 and 9.0000001, then it would be false. So actually, it's surprising to me then, are you comparing the first element of sample 3? Or are you comparing the first element from sample 1?
So I have it written the exact same way you do, just without the print statement. Like there is no print statement. It's just is equal to
So if
sample
you
4.
don't have a print statement, here, do you want to share your screen? So if you don't have a print statement, the code block will only print out the last thing that was run. And then we can get to your question next, Adina.
It's actually sort of a part of it, but mine says 9.44 for the first element in sample 3. And then for sample 4, it's 9. So maybe that's why we have false.
I see this. Then yeah, that would be false. This would be
then yeah, that's what I have as well.
Okay, let me reshare my screen. This is just an error in the solutions document. So, and just for everyone to see here, it says 9.44. For some reason here, it's 9.00. That's incorrect. It should be 0.44. So yeah, this would be false because 9.44 is different from 9.00 or just 9. So if this were 9.00, like we just saw, then mathematically these values are the same. So it doesn't matter that one's an integer and one's a float. Python will view them as equal, which is good because that's true. But then if it's off by any decimal place, then they're no longer true. And then, yeah, the evaluation returns a Boolean. Okay. So here we get chaos, which is a variable that contains a lot of data. It has some numbers, it has some strings, and it also has some Boolean values. Oh, and it has strings as floats and as integers. So what is this structure called? Answering this question using a print statement on a full sentence using an F string. So first you can check the type of the data. Then using an F string, it would be something like print with the F. This is my data type. Type chaos, because the square brackets is telling Python that I want to read this as code now. Then it looks like there's quite some duplication going on in chaos. Can we convert this to a different data structure to get rid of the duplicates? So we know something like a set has all duplicates removed. So here first I have chaos and we print chaos as a tuple. And then we use the F string to print chaos as a tuple. Then we check the individual elements in the list, or in the tuple, excuse me, and we can see that the individual elements still retain their data type, but that this is now reduced. If we print all of chaos, it's reduced to the unique elements, and that's because we took a set of the original tuple. But another thing that you have to notice, and this is actually something I recommend you don't do when you code because it's likely to lead to errors. So chaos is an element, it's something that exists within Python, and it has these duplicates. It's possible that when I'm coding, like if I'm doing data analysis, these duplicates could be important later on. So I would create this set from chaos as a different name. Like I would do like chaos unique, for example, to indicate that this is just the unique items from chaos. This way, I don't actually override my original chaos tuple, and I'm less likely to try to, for example, count the number of observations and not be able to because I've overridden the original item. Yes, Alicia.
I had a similar thought process just because also the instructions say like return chaos back to its original like structure. So what I did is I just set a new variable equal to chaos, and then I did change chaos. But I have the original form of chaos
Mm,
in a variable I called original chaos.
yeah, that's
So
perfect.
is that a more efficient way to do it, or is it better to leave chaos untouched and then make a different, like, or have, like, do the changes to a different
Right.
variable instead of chaos itself?
That's a good question. It actually, I would say it really comes down to personal style. So I personally prefer this method where I try to have my objects, like my data frame object, for example, be a unique name for all of the steps, like until I do something to the data. So, for example, I want my data frame object, that's my raw data before I do any quality control. And then I want my data frame underscore filtered for filtering out contaminants. And then I want like data frame underscore log for data that's been log transformed. That way, if something goes wrong, I can easily trace back to figure out where something went wrong or where I dropped pieces of information. But it's also perfectly appropriate to have something like you said, where you're making chaos original equals as a tuple chaos, just to have the original saved somewhere. And at least doing this until you've confirmed there's no problems, because there's always problems and it's always unpredictable. So this allows you to still access the original data. One thing that you want to note within Python is that I don't want to do this. So I don't want to make chaos original equal to chaos, because then if I make changes to chaos, it'll automatically change my chaos original. So then I could accidentally lose it. So one way to prevent this is to just save it as a type. So even though chaos is already a tuple, when I do this, save this thing as a tuple, Python is treating this like executing a line of code versus Python is treating this as two data frames or two objects within Python being equal to each other. So, for example, in a data
Sorry,
context,
Emily, can you show them what would happen if you overwrite it? So at the end, you change it to something else and basically lose your original data frames, just to kind of demonstrate that error because it's actually really critical.
yes. So with the example of overwriting it here, we saw that with the original solution, which was that if I, here, just make this chaos and not chaos unique. So here I print chaos and I print the type of chaos before I do anything else. And I can see it's this long tuple and that it's a type of tuple. Then I take a set and I override this variable chaos. And then when I print out chaos again, I can see it's a tuple that's only 3 elements long. So this is likely to lead to errors if, for example, I'm trying to count the number of observations of something within a data frame. I would only count one observation per category here. And I might think to myself, well, I know that's wrong because I know that I have more than 3 pieces of information in the column. And it's just very difficult to pin down this type of error because it's hard to figure out, especially when visually this all looks identical, right? Like it just says chaos, chaos, chaos. So like nothing really stands out. So it's just much harder to figure out that this is the line of code where I've overwritten something and this is why I don't see that original data I expect to. Versus, let's try something like this. So, oh, this worked this time. So this time this worked, but bad practice, don't do it. So this time if I make original chaos just equal to chaos, then I still happen to have this original list. But again, this is bad practice because especially if I run, let's say we have this, we have 2 code blocks. Okay, my cat is very much sitting on my computer. Multiple code blocks that we're running. In this case, the function of the code hasn't changed, so I should still get the same result. And I do, but we're going to be doing things that are more complicated than this when we're working with real data, and we're more likely to run something here and then run something there and then try to access the same variable and accidentally overwrite it. It just, these are just issues that are difficult to troubleshoot, and you can, if you update original chaos, like let's say equals as list, and then I want to print the type of original chaos, and I want to print the type of chaos. Yeah. Well, it's proving me wrong. So here, what I would expect is that if I change this list of original chaos, that it would make both of these, I would expect to return the same list. In this case, it doesn't. I think this is actually dependent on the version of Python that you use. In old versions of Python, it would update chaos as well because there's only one equal sign here. To avoid potential issues, just specify that this is a separate entity. Basically make Python execute some type of code. That way it doesn't create any kind of override issue. When you're working with real data, we could say this is data frame filtered for the contaminants being filtered. And I would do it like this. So PD, this is pandas, dot data frame. This is a function from pandas. And then I would say my data frame, just depending on what the code is. So it's the same principle as saving it as a tuple. I'm just saving it as a data frame so that one doesn't overwrite the other. Okay. Anyway, do we have questions? Thank you for the comment from Nori. Yes, it's this is the type of error that's really difficult to debug. Yeah, Alicia.
I don't know if you went over like the last thing that we were supposed to do in this task, like figuring out what data types are in chaos. Is there, so the way that I did it was I just did a for loop and then I just printed the name of the item and like in an F string and then the type of the item. And so I went through every single like item in chaos and it gave me the type for it. Is there a way to only like there's obviously repetition when you do it this way because now I have every single item listed out and I have items like classes that are showing up multiple times. Is there a way to just to do it with just showing the like the unique classes without like doing it like because you did it in the index way, but what if you don't like know the indices, or is there like a more efficient way to do it is what I'm trying to say.
Yeah, do you want to send, or do you want to show us your, no, send it in the chat, your code, just so I have it and so that everyone can see what you're talking about. But what I understand from Alicia is that you basically said for item in chaos, yeah, you do print an F string, which is item, item, and then type of item. And your question was, how do you make this be unique?
Yeah, so like instead of doing it this way, instead of like looping through every single item, is there a way to just print the unique data types that are within chaos?
Ah, there's two ways to do this. One thing you could do is just take the unique items within chaos and then print it out like this, because then I don't get redundant lines being output. This is important if I need to know the value of the item and its class, or I could make a separate list of types equals an empty list, and then I could say list of type dot append, because I know there should only be one item added for each item in this for loop. Type list of type, and then I can print list of type, and this should be,
I think it
that
should
was,
be item.
you
Yeah.
are correct.
Okay, got it.
Yeah.
Thank you.
Yes, Adina.
So, I actually had a comment down because me and Alicia were comparing our answers, but our output kind of gave it in a different order. Like mine, I think I don't remember what order hers was in, but I can copy my order in the chat and then maybe she could copy hers. But I was just wondering why that happened.
You mean so like the order of
It
the
was the order
zero,
of
nothing, none?
the yes, but or oh yeah, because mine is zero, none, nothing.
Wait, I just ran my cell again, Anita, and it changed to that. So I don't know what happened originally,
I
but
think tuples are unordered. We can see are tuples ordered. I should specify. It doesn't have any impact on the code, because you're never going to code something where the order matters. Let's see.
Can you expand on why the order doesn't matter?
So basically, why I say the order doesn't matter is because when we're working with large data frames, we're never going to be accessing that data frame using this type of indexing. This is just one of these concepts that's important to understand, because this concept of indexing becomes relevant for more advanced functions that we will use in the future. But in general, it's actually considered bad practice to do this. This is called hard coding. So for example, here, this will only ever return the second item in chaos. And if I run code that reorders chaos, this item will change. And so let's say that I have data set from a list of patients, and I'm trying to pull out information from a specific patient who had a rare disease in a clinic. So there might only be one patient that had this rare disease. So I could pull it out using this type of indexing value. But if I use this hard-coded method where I'm doing it based on the location in the data frame, if I update, for example, my data file with more patients, maybe the order becomes different. And then I would no longer be calling out the specific patient that I think I'm calling out. This is why I say that indexing is not very important. But yeah, so the order, depending on the data type you're using, unless you're specifically using an ordered data type, like a set where it's like very firm and strict, it can change arbitrarily. It's not really a big deal, because when we access items, we'll be specific about what we're accessing as opposed to calling them by position. Okay. So now we have this dictionary called measured peptides. Oops. What is this data structure called? What is this data structure called?
A dictionary.
Oh my
Dictionary.
God, icons. Yes, it's a dictionary. So these are protein, or these are technically gene names. And then so there's this EGFR gene. It has 4 measured peptides. So now we want a list of all the values from the key value pairs, because if we remember, the elements of a dictionary are a key, which are these protein names, and then, or gene names, and then the values are the values that correspond to that key. And then we want to also sum up all of the values. And we want to do this using dict comprehension. So first we're checking the type because we just really want to be sure that this is a dictionary. And we're in fact so certain that this is a dictionary now, which is fantastic. And then we wanted to call out one specific key within this dictionary, which is EGFR. And so the way we do this, okay, so we see EGFR is not in our original dictionary. So we're actually adding EGFR to our dictionary, and we can do it this way. So we take the name of the dictionary, and then it looks like it's a list, but that we're just accessing the keys, and we're giving it this new key information that we want loaded into the dictionary. And we want to say that the value for that is equal to 4.
Emily, could you specify what would happen if we had added curly brackets around EGFR instead of the square brackets?
Yeah, I think it just returns an error. Yeah, because this is just invalid syntax. So these square brackets are good for creating a dictionary, but to access individual items in the dictionary, they don't work. So you can think of it as sort of like the dictionary has a list of keys. And so here we're calling a new key, and we're giving it a specific value. Amika has said in the comment, you can map /dict. I'm not entirely sure what, if you're saying like to apply a function across the whole dictionary, or how you intend that to be used. Oh yes, the data structure question. That is correct. Okay, so the question, there was a second question, which is that what's the sum of all of the values? So for all of the peptide counts, basically. So the way we access the values is by using this function. So here, first print measured peptides dot values, because we want to see, is this really what I think it is? It looks like it's really what I think it is. It's a list of numbers, so I know I can sum that up. And then here, the way I actually typically do this would be sum or count actually of peptides equals that, and then I would print counts of peptides. So the reason that I do this, as opposed to what you saw a second ago, is that this is much more readable. So here, and this again comes down a little bit to style, but if you are reviewing your code in the future, you know, you're debugging, you're stressed, you're tired. You don't want to think about what you're summing up in these values. But here I created a variable name that's telling me that this is a count of my peptides. So then I'm just printing it out. So this is another stylistic thing that you can consider. Then here we specifically want to use dict comprehension to generate a new measured peptide, taking the numbers shown here and doubling them. So because we're using dict comprehension, we're using a square bracket, the same way with list comprehension, list comprehension, we use square bracket, dict comprehension, we use curly brackets. And we know that we want to double the numbers that are represented here. So here, key and value are defined here. They're just variable names I made up. So I could make these less useful variable names. I could call this meow and meow meow, and that would still work. The code would still run, but it would be very confusing if I'm reading this code 6 months from now to actually know what I'm doing. So here I take the key and I multiply the value by 2. So I'm able to execute math just in line like this. And the reason I'm able to do that is because this .items function returns the key and the value. So if I print, for example, measured peptides.items, this is what it returns. It gives me a list with a key value pair. Yeah, Alicia.
So I just had a question. I was also wondering if it was possible to just do it in like to do math in one line, but aren't you then changing the original value, like what measured peptides originally looks like? So now you have like you changed the original like dictionary that you got. So I was just wondering if there's a way to like maybe not do that, to like maybe create a new variable but still do math in one line instead of,
Absolutely.
because I had to do a for loop when I did that.
Yeah, so this is a great question. And this is again highlighting how important it is to not override your data, because you're exactly right. I'm doubling these values. Let's say if I run this code again from here down, I would accidentally double it again, which means I have quadruple whatever the values were in my original list. So the way that I would choose to make sure I don't override my data is I would just do this. So it just depends on whether the original values are very important to you. I just take a more cautious approach because I'm a more cautious coder. I'm always worried that I'm going to have to go debug some specific step. So I typically save every single step as its own thing. And then if memory becomes an issue, after I've already checked out those items, I just write a line of code that tells Python, now delete these variables from the environment to save memory. We shouldn't be working at a scale where that's that important, but it's totally possible to do. And then if you don't check, you never know if these things are creating an error. But yeah. So yeah, you can also do this with a for loop. Here, we're using this inline method because this is the dictionary comprehension. But you can see there's already a for loop embedded in this. So the way that you would have this as a for loop by itself is basically just taking this part of it. Oops. And we say measured peptides doubled key equals to value times 2. And in fact, my style is typically like this: doubled value equals value times 2. So this should equal double value. The reason I like to split this up is that anytime I'm adding something to something else, to another list, updating a data frame, whatever, I like to make sure that I would catch these errors outside of the place where I'm adding it to the new thing. So I would even print value doubled value, because it should be obvious if this is working correctly then. And if I run this, it's not defined, that's fine. I see 0 and 0 correct, 5 and 10 correct, 4 and 8 correct. That's good enough. I checked 3. I made sure the math was mathing the way that it should. Yeah. And then if I check out the measured peptides doubled, there we go, we can see it. And I would have it like this. Measured peptides doubled. I'd make it equal to an empty dictionary because in theory, alternative method. So you can do it this way where it's as one line, or you can do it this way where it's in a for loop. Generally speaking, I prefer actually, or my brain tends to work such that I think in this method because I think it's more readable, but hardcore, like more computer programmers tend to prefer this method because it's sleeker. Instead of having so many lines here, I actually just have one line and it takes care of everything. So whether you use for loops or list comprehension and dictionary comprehension also just comes down to how you think about problems, and what you prefer when you're actually coding. Do we have questions about that? Okay. Okay, so control flow. This is thinking about the if, elif statements and these sorts of things. Okay, so we have this list of random numbers and it has 30 random numbers between 0 and 100. We want to use a loop to calculate the total sum of the numbers in that list. And then we want to use a loop that iterates through the list with an if-else statement to print out the highest number in the list. Then, if we still have the energy, we want to write a small program that can print out a version of this list that's sorted from highest to lowest. Okay, so this is our list of numbers, and we can see it's out of order. So there's 33, 36, 25, 4, 68, etc. So there's no order to this list. And the first goal was to use a loop to calculate the sum. So here, this is with the for loop. So for number and random numbers, sum plus equals number, which should add up all of these numbers one by one, and then we just print the final value at the end. Next, we want to pull out the biggest value. So we're using a for loop again, and we're creating an empty integer basically that's equal to 0. And then if we detect a number that's greater than our variable max, which starts out at 0, then we say our max is now this number. So every time we go through this list and we encounter a number that's greater than a number we've already seen, we update max to be the value of this new number. So then when we print max, it should be the highest value in the list. And then the last one here is to write a small program which will print out a version of the list that is sorted from highest to lowest. So here, I don't think this is the most intuitive way to do this, but it's more like getting you comfortable with this troubleshooting process and figuring out like what functions exist. So we iterate through a number from the total length of our list of random numbers. And then we still have this same code that you've seen before where we take the maximum number and then we, to this empty list, add the largest number. And then from our list of random numbers, we remove the largest number that we've seen so far. That way it should be a list in order from the greatest number to the smallest number. So we print all of this out. Did we get the same values? The sum for all of the numbers in the list is 1,403. Does this match what you found?
Yes.
Yeah. Alicia?
Sorry, I just have a question about part C. So I guess this probably wasn't like following the instructions because you did tell us
That's
to write
okay.
like a program, but I just used the sorted function and I just said reverse is equal to true and I didn't, and that sorted it for
That's
me.
perfectly appropriate. In fact, like I
Okay.
think this is definitely overcomplicating it
Okay.
because when you use the sort function, you turn all of these lines of code into one line of code, and it's also more intuitive, right?
Yeah.
So I think
And it's also
that's
like built, it's a built-in function, right? Like if it's already
exactly.
built in, then we don't have to rewrite it.
Exactly. And also like the sort function isn't something we reviewed, so you still got the practice of troubleshooting and having to get exposed to new functions kind of on your own. So I think that is perfectly acceptable. And in fact, this is also what I would do in a real life scenario. Okay. And then the maximum number, I got 99. Is this also what you guys got?
Yeah, I got that as well.
Excellent. And then, yeah, then we have this list here. Any other questions? Okay. So now we get a dictionary with courses and grades. Then we're going to take a function that takes this dictionary as an input and returns the average of all of the grades. So we know that we're interested in only the values. We don't actually care about the keys in this dictionary. So here so we're defining a function, we're naming this function, in this case, calculate average grades. We're using this placeholder named grades, and then calculating just the average value here. And I got 2.5. Is this what you guys got? Okay. There's a lot of different ways that you could write this. So this is why I said several times, like, there's multiple correct answers for coding things. So if your answers don't one for one match this solution document, that's actually expected. It's totally fine. Especially with writing functions, I think the way we write functions can really highlight the different way that our brains work and the way that we think about data and the way we think about problems. So I would expect all of us in here to write like the same function in a slightly different way. So now we want to take the first letter of each of our value or each of our keys and capitalize them just so it looks more formal. And we can do this by, we're making an empty dictionary. That is the new dictionary we want. And we're taking the first item in course, which is our key from our input dictionary. And then we're using the built-in upper function to make this uppercase. And then we're pasting the rest of the word onto it. And you can use this type of line comprehension. This is not necessarily the most intuitive way to do it, but it's an option that exists. And then it returns the dictionary with the capitalized first letter, and then all of the rest of the letters is equal to the grade as the value. Yes, Alicia.
So I didn't really know how to approach this question, so I did find like a Stack Overflow thread, and they use like a capitalize function. But could you just explain, like, I can paste the code that I have, but could you just explain how this works? Because I'm not entirely sure,
Yes.
like, why it works and why it works the way it does.
Let's see.
I guess it's doing a for loop again. But I guess, like, why does the for loop work, or like what is it doing?
Let me move around my Zoom chat so that I can see. Yeah. So this is the list comprehension format here. So it's dictionary comprehension, excuse me, because the curly brackets. So for first letter and lowercase letter in grades.items, first letter dot capitalize as the key, but this is just the value. So if we look at this, is this the whole function?
Yeah, and then I just did grades and I printed it.
So actually here just depends on this capitalize thing, capitalize the function. So I actually also think the naming of this is a little bit misleading. So I'm going to delete lowercase letter and make this value, because this is just the value, not a lowercase letter. And it returns the same code. But so capitalize function Python. I don't know if this is a built-in function. It is a built-in function. Very, very cool. So yeah, so the capitalize function is a specific title, is a specific function which is only capitalizing the first element in a string. So as long as your string is an input, or your input is a string, then that's fine. And then it looks like there's this cool title function as well, which will also capitalize every word as it makes sense. So that's quite nice. That's cool. So I have actually only used dot upper before, and I haven't used capitalize before. So was the whole function
So
supposed
sorry,
to be?
essentially what it's doing is just going through each like key value pair and then capitalizing the key, right?
Exactly. And the
Like the
reason
first element.
we know it's doing that is it's using this dictionary comprehension thing. So
Okay.
grades.items is giving us each element in the dictionary, the key and the value, which is why we have here, let's say this is
Oh, I see. Got it. Okay.
this is a little
So
bit
an
more
item in a
informative,
dictionary is both the key and the value or the values that are connected to
right?
the key. Okay.
Yes.
Okay, thank you.
And this is why it can be good to also print out all of our intermediates so that we see, okay, we're getting math in 3.0, we're getting informatics in 2.7, etc., etc. So it's both of these things that are being returned as the first element in grade.items. Oh, it's grumpy. That's fine. It doesn't like that because that is the incorrect way to use this. So did this answer your question, Adina?
I was asking, like, cause I did mine where only the keys, like the first letter of the keys were capitalized, like not like the whole dictionary. Like it didn't reprint the whole dictionary with the capitalized first letter of the keys. And I was just wondering, like, was it supposed to print the whole dictionary with the first letter capitalized, or just like a list of the keys
I
with
see.
the first letter capitalized?
So based on how this is written, we want to return the dictionary with the capitalized course names. But if you have now a list of the keys with the capitalized course names, then you can just write that as the new key values for your dictionary. Okay. Okay. Are we okay with me to go to the next one? Okay. Okay. So here, I don't think we talked about lambda functions. So define a lambda function with a list of words as inputs, which uses map to repeat the word each time. Apply this function to the courses. So a lambda function is an anonymous function, but the way you see this most often would be when you're using pandas. Import pandas as PD. Let's run that because I want you to see things with the syntax. Let's say I have a data frame. I would do data frame.apply. Apply is saying I'm applying this function either to all of my rows or all of my columns. A lambda function is nice because it tells Python just grab that whole row or grab that whole column, and it would look like this. Lambda x. So x is once again just a made-up thing that I have created, like a made-up name. And it's basically saying for whatever we're grabbing from this data frame via apply, do something to it. So I might call out specific columns and make a new column. And then I would have to say axis equals 1. When we'll get into this when we talk about pandas today. This axis equals 1 is basically telling the dot apply function that I'm doing this calculation row by row instead of column by column. So the default is axis equals 0, which tells dot apply that I'm doing the calculation column by column instead of row by row. Okay. This is the way you're the most likely to see the apply function or the lambda function. It's also called an anonymous function. I think this makes more sense in the context of pandas. I think this makes a little bit less sense, or it's just harder to understand, and it's not very similar to other things we're going to be doing. So I'll go over this briefly, but I don't think that this is going to be the most useful example necessarily. But we're defining a funny function, which takes this thing called word list. We have, again, lambda word, multiply that word times 3 from word list, because here with map, we're taking the element in the first position, or taking the function in the first position and applying it to the second item in the map function, and then it should return this as a list. So if we look at the grade keys, it's now a list of these repeated items. If this is a bit confusing, this is okay. We're going to go over lambda functions in the context of pandas. Okay. And then I'm also, go ahead.
Sorry, I was just gonna say that mine printed not like it didn't leave a space or enter um for like each repetition. I was just wondering why.
So it can depend, like if we have anything that's different here, it could be slightly different, or if we have like anything different here, it could be slightly different. So it's more about if the values are the same as opposed to like the way that it's printed out is just stylistic. And these are also settings that you can change. So for example, if you run this in VS Code, I don't know if you would get it printed out list by list like this. If you want, you can send your code for this part in the chat, and I will see side by side and see if there's like a difference that would lead this to be different. Let me add a code chunk. Okay. So we can see that we have the same dictionary for grades. We're taking this print keys list, and we're using the capitalize function to capitalize the first element, the first letter, and then we're applying this map function. So we're taking course, we're adding a space, and then we're doing that times 3, and we're repeating the courses. So for yours, it's probably just that it all fit because of how there was a space, so it took up slightly more space. So it could be that the default setting changed. It could be that, so you have your function applied outside, and then you're printing your repeated courses as a list in your print function, versus for mine, I'm applying a function on grades.keys. And I don't have a specific print statement, so just having it be this minorly different, like having it execute the code and then print versus just executing the code, could change how it's printed. Functionally, it's exactly the same. Like there's no difference. It's just a stylistic thing.
Okay, thank you.
Okay. I want us to take a break soon, but I will just go over this optional task very quickly. Again, this is just trying to get you comfortable with troubleshooting things within Python. So here we wanted to write a function that takes a human DNA string as input and would return a protein sequence. So this leaves a lot open. So I don't know if any of you guys actually did this, but here we have a function called DNA to proteins. And then in DNA, we have codons. Or go ahead, Alicia.
Sorry, you can explain first. That's I can.
So codons are 3 nucleotides in a row that get translated into amino acids, and those amino acids end up getting chained together to form a protein. So here, this is the code of which nucleotide sequences or which codons correspond to which specific amino acids. And there's also specific codons which correspond to stop sequences, and specific codons which correspond to start sequences. So here, I think these are all stop sequences, TAA, TGA, and TAG. So here, I should have changed this example because I think this is biologically a bit more complex than what is reasonable to expect of you. So the reverse complement is like the reverse complement strand of DNA. So as you might know, DNA is double-stranded, and so there's also 4 nucleotides. Here they're represented as A, T, C, and G. and A always pairs with T, and C always pairs with G. So if we have a double-stranded DNA, if I have an A on one strand, I know that this is paired to a T on the second strand. Then if I have a C on one strand, I know that this is paired to a G on the second strand, because A always only pairs with T, T only pairs with A, C only pairs with G, G only pairs with C. Is this using a dictionary? Yes. And we know that because this here has the curly brackets. So here, this is saying if I have an A, I know that I then have a T. If I have a C, I know that I have a G, etc., etc. Reverse DNA is taking DNA. Okay, so our input should be a DNA sequence. And then we're taking the reverse of that DNA sequence. Then we're taking our reverse complement dictionary, and we're taking this reverse DNA list, I guess, and we're going for each letter in this, for each nucleotide, if finding what the nucleotide is, and then finding the pair that it should be paired to. So this is the reverse complement of the DNA. So we have the strand that we're actually looking at and measuring, and then the complement strand. Okay, then, again, this is a list of codons. So these are 3 nucleotides that correspond to 1 amino acid, and it's always 3 nucleotides that are corresponding to 1 amino acid. So we want to look at 3 nucleotides in a row, basically, and after looking at those 3, we want to look at the next 3. We don't want an overlapping window. And so this gives us a reading frame. And then we're looking for a DNA strand in our DNA list and the reverse complement. Then we're seeing if this DNA strand, for example, here, so the codon would be the position plus 3. If that codon matches this ATG, this is the start codon, and then it can do other things. If the next codon is one of these codons, these are stop codons. So we know that we have to stop our amino acid sequence. Let's do this. Okay, and then if this next codon is, so if the next frame that we have for some reason is less, like we don't have enough of our DNA strand left to look at another full 3 match, or if the next codon and the next codon would be a stop codon, then we stop trying to find new codon or like new amino acids on this strand, and we add this to that protein list. And then here is just an example of that function being applied. So here is a list of a DNA sequence. It's just a lot of A, T's, C's, and G's. And then if we apply this, the function spits out these sequences. And then we can see that these match these expected proteins. Okay, so go ahead, Alicia.
So I was able to like write some code for this, and I was able to get most of the expected proteins, but my output isn't showing the 6th expected protein. And also, I guess my like related question to that is like, do we need to treat an internal methylene like an M when we're reading a specific frame as a new starting point, or like even if it overlaps within like a longer protein sequence? Because like how would I do that in my code? Especially considering the fact that I think expected protein 5, it has a methionine within it.
Mm-hmm.
But then everything after that is also protein 6. So I'm kind of confused on why it's, I guess, why protein 6 is embedded within protein 5, if that makes sense.
That totally makes sense. So to highlight also for everyone here, this entire protein 6, you can see exists right here within protein 5. And the question is basically like, does this make sense? biologically. Is that right?
Yeah, and then also like how would I code it out? Because I don't have protein 6 right now. I just like my output stops at protein 5.
Mm. Yours is probably more closer to a biological truth then, because if there's like it's not just a start codon that will tell DNA, okay, start sequencing here. There's like whole promoter regions and a bunch of things that go into DNA deciding, or like the DNA replication machinery to decide that this is where I'm going to start replicating the DNA. So I would actually say it's more of a fault of my code that it will take a secondary protein that is like a subset of an existing protein, because this is probably not something that would happen in real life. But if you wanted to, it just depends how we coded this differently. It could be because my code is going frame by frame, or like these 3 by 3, and maybe yours is going once I catch a start codon or a starting sequence, go until I catch a stop sequence. I suspect that's why they're different.
Yeah, that's what I have. I guess I was also wondering like why there would even be a methionine within a protein sequence. Like how it could be like possible for there to be a methionine without there being a stop codon right before it. I don't know. That just like I because isn't
Yeah,
methionine like specifically a start codon? It's not used for anything else, right?
I think it's not impossible. I think it's just not probable. Also, this is a made up list, so of DNA for the sake of the
Oh, okay, got
example.
it.
Yeah,
Yeah,
but
so for the way that I did it, it's like I have if out like if and elif and all those else statements. Just saying if the amino acid that you find from the codon is an M, then you build the protein, and if you come across the asterisk, then you stop building the protein. So yeah.
Adina, did you have a question as well?
Yeah, I wanted to print my code in the chat, but that's what I had so far, but I wasn't able to like start breaking it up then, like where the stop codons are and like move on to the next line. So I was wondering like how kind of that could be finished.
Put this here. Put this here. And it did not save the indentation. Okay. Let's assume this is like this. And then I assume this is like this.
That 4 is actually I had it not indented. Like it was outside of the first 4.
Like this.
Yeah.
So yours is written as for loops, not as a function. So here you're saying if for codon in codons. Codons is this DNA example, taking 1, 2, like the next 3 for the full length of the DNA. Okay. And then you now have a list of your codons. Do it like this. So you have this list of codons, which functionally this might be fine, but it might be more useful to wrap this also in like a bigger, basically paste this code here, just so that you know you're going from one codon sequence to the next. And then if codon is in codon table.keys, I don't have codon table as a dictionary here. Oh wait, yes I do. It's given to us. So here, the codon table. But this is within actually this function. So this variable technically doesn't exist outside of this function. So we would also want to save this as a dictionary in the environment. So now I have, if the codon corresponds to something that I know could be an amino acid, take my amino acid string, and make it amino acid plus codon table equals the codon, or the amino acid that corresponds to that codon. Then I would actually say you want something, I see, so that in the end you would get one really long string. Let's just look at this. So in the end, you get this string that has codons up to the stop codon, and they're all spursed together. So then you could just take amino acid dot split, and you want to split by an asterisk. Now Python will, why can't I type? Python will read this asterisk as what's called a wildcard. So basically it'll say like if anything matches this, but you want to say I literally mean an asterisk. So we use a backslash. I might need to use 2 backslashes. Let's try it with 2 backslashes. Let's try it with no backslashes. Okay. So now it gives you this list of proteins that you detect. And your proteins, as you can see, are slightly different from the other proteins. Especially you don't check here, you don't check for the start codon. You don't check for the start codon here. So you just go through the entire list, regardless of if it is indicating a start codon or not. So here we have an ATG starting, but we also see, for example, an SV amino acid sequence, and we probably don't expect that because we expect ATG to be our starting sequence. And what is S? It could be a couple things, but it's not ATG. There's all these other S's here. So that would be one reason your list is different. And then it could also be because how you're splitting your list. Where is your list? Here. So here you're automatically going for every 3. I don't know, for L in range, the length of this list, take every 3 items versus and you also this function is checking the forward strand and the reverse strand of DNA. So that would also be why we have differences. Okay. I expect that to be the only reason that there's differences between our 2 functions. But I would say this is actually quite a complex problem. So if you guys were already able to troubleshoot this, I think that's a good thing. You're already trying to think about biology in the context of relatively complex coding. Yeah, so Nori has said in the chat that the protein sequence has M in several locations for structural reasons. That it can happen. It's not the norm. So this is why you could have an M in the middle of your, here we go.
Yeah, that's for human myoglobin protein.
It's here. So yeah, that's why it could be in the middle of a protein sequence. Go ahead, Alicia.
I was just wondering if, like, maybe during the extra hour that we have, or maybe after we're done with like the whole class, if you could just check my code and like help me figure out if there's any way I could make it more efficient and things like that.
Sure. Did you have any problems with it that we haven't gone over in the class today? Or is it
No,
just for
just other
efficiency?
than just for efficiency, because other than like the 6 expected protein not showing up, I was just wondering if I was approaching the problem not correctly, but like in a simple and like efficient manner, just to like improve the way that I could.
Yeah, I can take a look at it. Yeah. I mean, the hard thing is that there are so many ways that you could do it. And in this case, like all of these things are really small. So we don't have huge memory problems. And we shouldn't have huge memory problems for the data that we're going to look at. Um, and the things that I would say might be more efficient, a different programmer might have something different to say about it. So just know that like my opinion could be different from somebody else's and we could both be valid. It depends a lot on context. But since we've been going for a while now, I would like to take a 10-minute break so we can come back. What time would it be for you guys? Just before the top of the hour? So at 58?
Yeah, 11:58.
Okay. Then see you in 10 minutes.
Great, thank you.
Okay, is everybody done with their break? Let's Okay, I'm going to share my screen. So now we're going to transition from sort of basics of Python to introduction to Pandas. So Pandas is a module or package for Python that allows you to do like create data frames and do things with them. So it's basically something we will always be using if you are in like bioinformatics or data analysis. Here we go, slideshow. So I'm not going to have us like break out in for a small group discussion because these can be painful. But when you are using Microsoft Excel, there's a lot of problems that you can encounter. The first being that Excel will often change the names of genes into other things. Like it will change gene names into date types, or it might accidentally shift your rows or shift your columns. In general, when you're using Excel to produce an analysis, it's not something that's reproducible because I have to point and click in Excel exactly the same way you did. Versus with running a script, in theory, I could just press run and I should get exactly the same result that you got when running the same script. Okay. So Pandas is what we're using to create data frames and to manage data frame objects. So it's good to be familiar with the basics. It has a ton of built-in functions, and there's just no way that I can expose you to all of these. In fact, there's many I still don't know. And usually you learn them because you're searching around and you're trying to find a specific function to do something very specific. So like the same way that you guys with the Stack Overflow post came across the capitalize function, this is the same way that I learn about things within Pandas. So there are some technical words that you should know because they'll come up in error messages that you encounter, and it has to deal with how Panda conceptualizes a data frame. Okay, so first is that you can have what's called a series, which is like one-dimensional. It's sort of similar to a list, but it's a different type. It's a series, and there's a data frame. So here, this is a data frame that has rows and columns. If I take one specific column of this data frame, like name, this is the series. So individual columns are saved as series within the data frame. And sometimes series will have their own specific functions. So you might get an error message that says something like X has no function Y, or you could get an error message like series has no function Y if you think you're applying a function to a whole data frame, but you're actually applying it to just a series. So this is why it's just important to know these names. Within Pandas, you also have so each column will by default have a unique name. If there is a repeat, Python basically adds a tail to the name of that column, which is like _X and _Y, in order to have those unique names still encoded somehow. And it will also give what's called a row index value. By default, these are just going to be numbers, and this is the order of the rows in the original data frame. But you can also make columns of your data frame your row index value. You usually want this to be the most important unique identifying information in your data frame. So from this example, name would be a good index value because it's something unique that corresponds to each row. And it's a way that I could track the information. Like here, I have information for some specific sport that is a favorite of this person, or that's playing, I don't know anything about sports. It's a sport that these guys are playing, but maybe I'm also interested if they live in the same neighborhood. And maybe I have another Excel sheet that has like the district of the city that these people live in. Then I could look at, by using the name, this is the information that would be the same against these two data frames. I could see if people who work on the same team live in the same neighborhood or live closer to each other than people who work on different teams. Okay, so Pandas makes things a lot easier and it also makes them a lot prettier. But in general, Panda functions are overloaded, which means that they're not necessarily the most efficient way to do things. And they can also do things very differently. Like the same function can do something different depending on how you feed the parameters to this function. And yes, and there's often many ways to do something, even just using functions within Pandas. So there's no one best solution. And especially if you're thinking about efficiency, there's not, Pandas isn't going to be in general the most efficient option, but it is very easy and it is very fast for getting something written. And most of the time that's going to be the priority. So the best solution is just the one that you can write. The best tool is the one that you can use. At this stage, especially because we're still learning, if we're hyper focused on efficiency, the efficiency gained would be so small and so minuscule that it could actually take away from your other learning. Because if we wanted to be the most efficient, we wouldn't use Pandas at all. But yeah, that is when you're working on the scale of terabytes of data, and we're not doing that, so it's fine. Okay. Yes, and so sometimes when you really need something to be very fast, there are other functions, like you can take your Pandas data frame and you make it a different data type that would be more efficient, like a NumPy array. We will not be working at a level where doing this type of thing would ever really matter. Like nothing is that big for us that that's going to make such a huge difference. Okay, so just going over some examples of a series again. A series is kind of like a list, but it's a different data type. It would be like it's a named list. So here we can see there's a series of this protein intensity, and it has the row index value still as a component of the series, and it also has the name. So here this is actually a dictionary that's converted into a series. This is the same gene names that you worked with in the task module, and just using the pd.series function. And boom, we have it. And then, oops, now when we have it as a series, we're able to do evaluations. So here we can say, are the intensities greater than 10? And for each element of this series, we get whether or not that's true or false. So this can be really useful if, for example, I have a list of patient IDs and those patients are in they're either in treatment or control, and I just want a count of, or I just want to see, is this patient, did they receive treatment or did they not receive treatment? This is one example of how I've used this recently. And when it returns these true or false values, individual true and false values are Booleans, but this whole item here, this whole evaluation, it is returning a series because it's many values put together in the context of their row index and the series name. So if I had a list and I made this into a series, then the row index values would just be numbers. But because this is a dictionary, I have these keys that have specific information. So these keys become the row index. So using these true and false Booleans is very useful just to get quick counts of things, but it doesn't let you subset a data frame based on what's true and what's false. You have to apply that within another function, and we'll talk about that. Yeah, because it's some of the basics. Okay. So you can create data frames from scratch with dictionaries and series objects. This is mostly just useful for examples, and it's useful for solidifying your knowledge of like what is a series versus what are the indices, and like how is a list being used. But we are just going to be using basically an Excel sheet. We have a data table already, and this is what we'll be looking at on Monday. But it's good if you guys can practice with this just to get really comfortable with this terminology, because a lot of error messages are going to use this terminology. So I do think it's important that you're familiar with what these terms mean. Like, for example, the index. So here we have series 2, and we can see the index is in this weird order. So our series is also this list that's in this weird order. When we want to put two series together and retain like the original index value, for example, this becomes a data frame. So here, series 1 becomes row 1 and series 2 becomes row 2. And then it automatically sorts the column names, the index value becomes the column names. And then so this really messy series number 2 gets sorted out because of those row index values. But you can also make series 1 column 1 and series 2 column 2 using this method. So it sort of looks like a dictionary, but you have to specify what you want that row name to be because you're not using the index value. And so here I say my column name first is going to be series 1, my column name second is going to be series 2, and these sort of look like sort of look like a dictionary. So you can think about it sort of like the name of the column as the key and the value as the information you want there. Sorry, I have hiccups. Okay. So sometimes people are using NumPy arrays, but again, this is really just if you're trying to speed up a math calculation, and I'm trying to keep us away from doing that because I feel like it's making it more complicated than it needs to be. Also, Python or Pandas can read in Excel files, which is really nice. So we're going to be working with like TSVs, which are tab separated files, and CSVs, which are comma separated files. But I think some of the metadata is stored in an Excel file. We don't have to convert that to something else. We can just read it straight into Python like that, which is very convenient. Okay, critical functions that you will definitely be using. The first is read underscore CSV. This is how we read in data. This is the most common function you're going to be using. And so, sorry, I keep pressing buttons on my computer. Okay. And so it's just pd or pandas.read underscore CSV in the name of the file. Now the location of your script really matters for how you type this. So let me, for example, pull up again my VS Code file. So here you see I have, is this text big enough, by the way? Do I need to make this bigger? I saw a nod as in, yes, it's big enough. Don't worry about it. Okay. So here I'm using pandas. So here I import pandas as PD because I don't want to type out the whole word pandas every single time. And then I use the function read underscore Excel to read this Excel file called curated metadata peveds. Now you can also see that this is in some other folder called data. If I run this now, this won't work because if I look in my folder, I don't have a folder here called data. So there's nowhere for this, this path doesn't exist. If I were to try to open this inflammation biomarkers.xlsx, that could work because this file really exists. However, this file, this document here, which is called W6, I don't know where this file is saved. Or here, I can see it's in users, Emily downloads here. So this is a different file location than this, which is desktop/tomb/inflammation here. Users, Emily, OneDrive, desktop, tomb, inflammation biomarkers. We will set up our folders together on Monday, so that to try to avoid having this type of problem. And I'll make a note of that too to make sure we do that. Set up project folders on Monday. And I'll show you some best practices that I recommend. But if you get error messages before you can even read in the file, it's very likely due to the fact that the path of the file is not correct, or it's the wrong function for the type of file extension or something weird like that. 2CSV is when you're trying to say you did something to your data frame and now you want that saved as a file that you can open and share with collaborators. One example of when you might do this is if you have a data frame of the contaminants that you read out of you remove basically from further analysis. Usually you need to share this list of contaminants with your collaborators. So you would use or dataframe.2CSV to save this somewhere so that you can show them, look, these are the contaminants. They really are contaminants. So we wouldn't remove them from the data. Okay. And here is an example of this in practice. So here, if we have our mini data frame, which has a couple of rows here of different proteins, and then the number of peptides in that protein, their intensity values, and some score. We do a calculation so that now we have the log2 value of those intensities, and then we save this log2 transformed data to a data frame that can be shared with other people. Yeah. Lock and iLock. iLock I basically never use in real life, so I'm actually, anything in the task modules involving iLock, I think you can ignore. The reason for this is that iLock is using integer-based indexing. So this means that iLock is using hard-coded locations to access information in the data. And I just told you that we don't want to do that, that anything that's hard-coded is less reproducible. Lock, I use all the time. So lock is basically short for locate. So I'm telling this function, okay, apply this on a data frame, locate rows that match some label, and then go locate the columns that match some label. And notice that lock is always going to expect row and column information. So here, if I want to consider all rows, then I still have to give some sort of argument for this row label, just because the function is expecting to receive something. So here, using a semicolon just says, look at everything. Oops. And then let me just clear all my drawings. Okay. And then so here, using .lock, I'm saying look at all of my rows, and then I only want column names that fit this list. So I only want a column called peptides, and I only want a column called score. And then it prints out my entire data set, but with these columns. So this is one way that you can subset the data based on certain columns. This is another way here. So here I'm interested in row values. This can look like it's two lists inside itself, but this is basically a list for the rows, comma, nothing for the columns, because it's all the columns for these rows. And so here we're also using what's called an exact match. So here I'm specifically interested in rows that have this index value, RKA and RKB. These are specific proteins that are in the same family. And then here is just another example. So you can also, instead of just subsetting the data, you can also access specific parts of the data. Like here, I'm taking the MYC peptides. So where my row index value is MYC, change my peptides value to 5. And then when I look at the data frame for MYC, I see my peptides value is now 5, whereas before this peptides value was 2 that you can't see because I just drew over it. So this is .lock. You get comfortable with it through using it. So we'll go over this again on Monday with the real data, because I think it makes more sense in practice. But this is something I use all the time for subsetting the data, either trying to select just certain rows, or let's say I have usually like a sample ID as my index value, and I want to subset my samples by only those belonging to some condition. Okay. And these are just more examples. So you can also say, for example, just give me the data frame where my score is greater than 100. If I run this line of code like this, it gives me back this Boolean value. So it gives me back all the rows of my data frame. It was just true or false, but this isn't subsetting the data frame. To subset the data frame by this condition, I do the exact same thing, just inside of a lock argument. And then let's say all of our values below 100 are actually just low confidence reads. And I don't care about the value below 100 because I think all of them I'll mentally consider the same, which is the low confidence read. Then I might do something like this. So everywhere in the data set where the score is less than 100, just make it 99, because then it's easier for me to track where those low confidence reads are, because they all have the same value, so I can pull them out by filtering in the same way. And it's just simpler. So iLock, we don't care. We're not going to do that. But this is going to be, I would say, the most common way that you're using lock, which is for subsetting the data frame by some condition. And notice that this prints it out. This doesn't save it anywhere, right? So I always print it out first because I want to see, like, is this doing what I think it is? And then I would save this to mini-df subset as a new data frame that has a subset of the rows of the data where the score passes the quality check. Okay. Okay, and then here, here's a Pandas built-in function. So .columns is going to return a list of the column names in your data frame. And now I'm using this other built-in function called isIn. It's quite straightforward, right? Like, it's just checking, is this thing you're giving me inside of this other thing inside of the function? So here I'm checking to see if intensity and score are in the data frame column names. And again, this is returning a Boolean, but if we do this inside of a lock argument, then we can actually just get this. So here we have, again, we still have to specify consider all rows, and then we're doing the evaluation. So lock is really powerful if you want to subset your data by something that's true or false, or if you're like trying to subset by specific mathematical values. Then you will also, there's really great functions for what's called descriptive statistics. So this is before you analyze your data frame, you need to understand what the data looks like, what's in the data, and what is the spread of the information in the data. So first, .shape. This is something I use all the time because anytime I'm applying a data transformation, I want to see, first of all, did I mess it up? Did I accidentally remove a bunch of things that I meant to keep? So this has here the rows by the columns. So I should have 5 rows in mini-df and 3 columns. And note that the row index will not be counted as a column. So this is especially useful if you're filtering out data, again, that like it doesn't pass some sort of confidence threshold, or it's detected as a contaminant, I want to then count how many contaminants I removed. I could do that by using this dot shape. Then we have D types. So this is a built-in function of Pandas that you apply to a data frame, and it will tell you what is the data type for everything in the data frame. So here, for example, peptides is all whole numbers, so it's being read as an integer. Similarly, score is all whole numbers, so it's an integer, versus the intensities are float values. This is a good thing to check because sometimes you'll have your integer columns being read in as floats, and this can cause issues, especially if you know you need to do math using these columns. Then you would have to convert the data type to be an integer. So just something to keep in mind, something you check on the front end. And this is one of the basic types of descriptive statistics I would expect you guys to do next week. We also have this awesome function called info. This is giving us, again, all the basic information we need just to see what's going on with this thing that we have within Pandas. Here we see it as a data frame, a Pandas data frame. It's telling us about the columns in the data. It's telling us about the rows in the data. It's spitting those out. And it also tells me some information about memory usage and such. Okay. What's more useful though, and more relevant for example, like writing a report, and more relevant to descriptive statistics outside of a programming context, is dot describe. So dot describe is going to give you, for every integer value, it's going to give you summary statistics. So all of this is going to tell me what my data looks like. So here, for example, with peptides, I have 5 observations. I see 5 observations for every single column, so that's cool. I know I don't have any NAs. I can see the spread of the data, and I could infer from this type of information if my data was biased in some way, like if I had more low value observations than high value observations. So I will also add this. So dataframe.describe returns descriptive statistics for integer numerical columns. df.valueCounts returns summary information for categorical columns. So for example, if I'm looking at what medicines patients are taking, dot describe wouldn't give me any useful information. It wouldn't return any information because medicines are going to be strings in those columns, versus value counts will return a count of the number of times each of those unique strings occurs within the data frame. Okay. So to keep it simple, we're not really going to be working at a scale. We're looking at the memory usage is really useful. So I'm just not going to go over it, but you can look at how much memory you're taking up. The more relevant thing is going to be these dataframe.head and dataframe.tail functions. So my most common, at the top of basically every script, I have pd.read_csv and then dataframe.head. Head will by default spit out the first 5 rows of your data frame. If you want fewer or more, you can spit out fewer or more. So if you specify 2, it will just give you 2 rows of your data frame. Similarly, tail will give you the last 5 rows of your data frame, or you can specify a number and it will give you the last few of the data frame. Especially before, I mentioned how if you're applying a transformation, I recommend you check one value, or one row throughout each step of the process to make sure it's happening correctly. I usually just look at the first one that pops up when I run dataframe.head. Yes, Adina.
So using this function, can you specify which ones you want? as you said, the tail kind of gives you the last 5, but say you wanted some from anywhere.
No, so to get them to pull out something more specific, you could use row indexing or data frame indexing, or you would use the .lock function. But so head would just give you the first X number and tail would give you the last X number. Sometimes you need to make sure the data is clean. So unique, you can look at the number of unique values for each column. So again, if we're looking at medicines, you know, there's a generic name and there's the brand name. So if I was looking, is it Advil and ibuprofen? I can't remember off the top of my head, but like if there's 2 medicines that are the same thing, but they go by different names, I would look at unique, or I could even do something like df column name dot n unique, or just kidding. N unique is giving you the unique number of observations per column in the data frame. Unique is another function that exists. And then you also want to, one of the first steps you do in data analysis and descriptive statistics is categorizing your NAs and then figuring out what you're going to do with those NA values. So the fastest way to get this is this dataframe.isNull.sum, and it just calculates the sum of the missing values for every single column. Because, for example, let's say I only had intensity values for a single protein out of all 5 of these proteins. If I only have one value, that's not enough to make a comparison. So I wouldn't want to plan my analyses upon something that would require something that doesn't have a lot of observations in my data set. Yeah, Alicia.
If we, in the sum function, if we say axis is equal to 1, would that count the number of missing values for each row then?
For, I actually don't know, because I think you would have to specify it in the isNull function.
Okay, but like it's possible somewhere in this function to like specify row or column. Like it's not just for a column.
It should be possible. To be honest, I haven't worked with this a lot, but it should be possible. But I would just have to look up the specific arguments for, or the specific parameters for the specific function. Yeah. Some other useful functions. So if you have an experiment that for some reason is spread across multiple Excel sheets, this is sometimes common, you can use .concat. So this is concatenate. It basically will shove 2 things together. So if we have this mini data frame that we've seen, but we have 2 more proteins, these are zinc finger proteins, and they have all of the same column names, then we can use this .concat function and it will automatically spit these 2 together. And this is because their column names are the same. If their column names are different, you have to combine these in a more complicated way. And we will talk about problems like that when we come across them. Yeah, so this is an example where this zinc finger proteins have an additional column in their data frame called family. And then we can see that this ends up being a fully NA column for the other, after we concatenate or merge this data. Okay, I'm going to skip that. There's only one thing I will go over here. So a function that you sometimes see is this .t. This means transpose. So this means you take your rows and your columns and you flip them. And you can see this written like this. So dataframe.t or dataframe.transpose. These are the same thing. And you can use them the same way. This will switch the rows and columns. The reason we would do this is that sometimes different functions might require your samples to be rows, and sometimes it requires your samples to be columns. But typically, in general, with our data, we want all of the unique observations in the data to be a row. So here, our unique observation would be a gene, and each of these genes should be one individual row with no repeats. And this is a concept of tidy data that I can also talk about more with our real data set on Monday. Yes, we're not going to use concat that much, so I don't want to go over it in great detail. And then some more advanced functions. So I do think it's important to just be familiar with .index. This is something I reuse in real life. And so here, the index of this data frame is these protein names. The reason this is important is that this is usually the identifying information that you're basing either a merge of two different data frames off of, or it's the important information for some type of statistic that you're running. And I do think it's important to just get comfortable with it. So there's also built-in functions for setting the index. So here we have data frame dot set index some column, and it would be some column in your data frame that you're making into the index value for the data frame. This is the most common too that I use. So then whenever I have to call out the columns like this, it's usually when I'm renaming the columns. So I might have something that looks like this. Data frame dot columns equals some list, because I want to rename the column names to fit some list of, usually I'll do this because I don't want to use column names that have a capital letter, because then every time I want to access that column, I have to capitalize the letter when I'm typing. And I will also do this if there are column names with spaces in them or periods in them, because I don't like these in column names, because it can just make it messier. Okay. You can use this rename function to rename your columns as well. I don't do this as often because you have to then be more manual about the old name versus the new name. I'd rather just give it a list. It depends how big the data frame is. So this .ag function stands for aggregate, and this is something you can use to apply a calculation to an entire column. So here we can get the mean value of our columns, of all the columns in the data frame, just by applying this .ag function. You can also make it more complicated, like you see here, where you have multiple functions being applied to different columns. I usually wouldn't do that. I only use the ag function if I'm doing something that I want super simple across the whole data frame. Okay. Now, .apply is the most common function that I use. And so you can apply these functions on a row, or you can apply them on columns. So here, this is the most simple format where I'm just directly applying one function to all of the columns here. So the default behavior is that it's going to apply a function to every single column. But oftentimes, especially if my samples are rows, I might want to calculate a value from 2 column informations per row. And then with that, you make the axis equal to 1. I also do not apply this with the lock function, so I'm not going to go over this. So merge. Another way of combining different pieces of information within pandas is to use .merge. And so you can have this as pandas.merge, or you can also have this as dataframe1.merge data frame 2. And there's a lot of optional arguments, or there's a lot of arguments that are not optional. So I have to give it some key value, matching column. That should have something the same between my two data frames. And this could be one column, or it could be a list of multiple column names. This is probably not something we're really going to come across. I just want you to be aware right now that it exists, that you might reset an index, and then you might merge. So left, I'm specifying this is the other format, data frame 1, right? This is data frame 2, and on by protein, because this is the column that is the same between these two data frames. So in this case, we're doing this because we want to combine information about other names for our proteins, just so that the document's more interpretable to people who work in our field, but also if we have proteins labeled by different names, we could use this information to basically push them together. And then we can see our data frame after the merge has the observations we had in our data frame and the alternative names. There's different ways that you can join. The default is an inner join, and this is usually not what you want. So an inner join is only going to take the things that are the same across these two data frames. An outer join is the safest type of join because you can still trace NAs, or you can trace the things that don't have a match. The other thing I would use a lot is a left join. So for example, we had this list of proteins with alternative names on our previous slide. Let me go back to it. If I have a protein that's has an alternative name, but I don't observe it in my data frame, then I don't really care about that because I don't observe it. So in this case, I would use this type of left join in order to keep all of my observations in my data frame and then only merge the alternative name where it exists for the things I actually observe. The right join would be the same, just by the data frame in the right position instead of the left position. Okay. This I don't use, and I don't expect you to use. Sorry, I'm trying to go faster because we spent more time reviewing the task module than I expected. So group by, this is an awesome function, especially when you're doing math. Like I might want to do a calculation here by different cancer types, or I might want to do a calculation by generation, or I might want to do a calculation by treatment versus control conditions. I do all of that just by specifying the column name that I want to group my variables by. And now this is inherently a grouped by data object. So every calculation I apply to it will be done by this group. And then you can easily add summary statistics. So one thing that is also really common is that, let's say I just want to apply a function to one column. I would have my data frame and I would use these square brackets to just call out that specific column. And then I would apply the function that I want to apply. This is something I do all the time, especially if I'm like just quickly trying to get numbers from something. I'll do this for the mean value. I'll do this to count the number of NAs. I'll do this for the value counts, because I don't always care about it for the whole data frame, especially if my data frame is really big. So I can get it for just the data frame that I care about here. Okay. You do have to be careful though, because sometimes we can forget that our data frame is grouped. So we might apply a calculation and expect it to be for the entire data frame, but we've accidentally applied it on a group by data frame. So the math that it returns could be slightly different. But also sometimes the behavior will also just be different, like the way it summarizes the data might be different or unexpected. So I recommend always before you save this somewhere, just visually inspecting the data to see if it's about what you think that should look like, if it's giving you what you were expecting it to give you, and then you can save it somewhere. Okay. And then we're not going to go over this example case because it's not relevant to what we're going to do, and I don't want to go for too long. Okay. And go ahead, Alicia.
So when we use the group by function on a data frame, the grouped like data frame is still a data frame, right? Like we can still apply the regular data frame functions onto that grouped
Yes,
table.
exactly.
Okay. And also when we are doing those functions, so let's say we did make a data frame and we use the group by, we apply the group by function on top of it, then when we do any like subsequent functions on it, let's say like sum or mean, is that going to be like by the rows that are grouped, by the columns that are grouped, or like how does that exactly work?
So typically we're grouping by column or by values within a specific column. So here we're grouping by this column oncotype. And then each row will have some value. And then the rows that don't have a value, according to whatever you're telling it to group by, are dropped. So they're not included in further analysis. So then you also have to decide, do I want to make my NA values equal to something like unknown? That way they don't get dropped. And then you can also have this, you don't have to save the data frame object as a grouped by object, or you can ungroup the data frame so that you can still use it to get like study-wide calculations and summaries, and then you can do the group specific calculations and summaries.
And so just a follow-up question. If we do like, let's say the sum function, what is it going to be summing? Is it going to be summing by like the rows that we have left after we've grouped the data, or like, I'm not exactly sure how that would work.
So you're talking,
Or just any other function, not even just sum. Right?
so you're talking about here for this specific example. Is that right? Like we're applying some on a specific part of the data?
Yeah, I guess so. I'm also just asking because the task that I was working on is like the optional task in module 2.2, and I'm kind of struggling with it. I'm not sure like how the group, like I don't really understand how the group by function is affecting the data frame. Also, I can't like visually get the group by like the grouped data frame to show. Like it's just an object, so I can't visualize it in any way, and I'm not sure if that's possible either.
I see. So here is, for example, if we were to print out just this, it would give us like a grouped data frame object, but then what it prints out would look exactly like this because the data within, or like the information within the data frame doesn't change. It's just that there's now a tie programmatically that is indicating that this is a group by object.
So when we print it, we have to specify the column that we're grouping it by to get it to print.
No, you can get it to print however you want. I'm telling you, if I were to print this group by data frame object, it would look exactly like this, except it would just say a grouped by data frame, like Pandas data frame column.
Oops, sorry. Can you hear me?
Yes.
Okay. So my other question was like when I tried to print my grouped data frame, it didn't print anything. It just gave me like it just says data frame group by object and like the place where it is, and that's it.
Then
If you want to see the code, I can show you the code, but
if you do your data frame, see, dot head though, like if it's still grouped, would it still print something out? Because to me, this isn't unexpected behavior. It's just that Python is weird about how it handles these things.
well, the way that I wrote it was so I had a data frame and then I applied I set the data frame to a new variable because I was grouping it by one of the columns. And
Hmm.
then I tried to print out the variable where the grouped data frame is stored. And all it gives me is pandas.core.group by.generic.data frame, blah, 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 at this
Right.
location.
That's fine because you can still use it in calculations. But if you use .head, it should be able to give you like the head of the data frame. Sometimes Python is grumpy about this because it inside the data frame, it's technically considering one data frame per group. So this
Mm-hmm.
is why I think it doesn't by default spit it out because it's just more complicated. Um,
Okay.
but this is normal behavior. You can still do calculations with it, and then the
Yeah,
data frame.
I
It's
guess I was just sorry. Yeah, I guess I was just like struggling with it because I like to visualize the data frame. Like it's
right.
easier for me if I can
Yeah.
visualize it. And it just wasn't working here. So yeah.
Yeah, I mean, I do too. This is why I also like the way that this is presented. I print out whatever the thing is I'm working with, and then I do my code below it, and then I go back and I check because I think it's hard to follow sometimes otherwise. Do we have questions for the last stretch of time? I think it's 10 minutes left.
I have a question. So I'm working on like the part B of task one. No,
Mm-hmm.
task four for module 2.1.
Mm-hmm.
And like I'm trying to get the can I share my screen actually?
I don't want to
Or
go over specifics for those
okay.
task modules,
Okay.
just because we're going to do that on Monday, and I
Okay.
want everybody to have the opportunity to look at it. But we can talk about like the theoretical stuff
Okay.
instead of looking like at the specific problem, so that we can still get your question answered.
Okay. Because like I'm just trying to figure out how to take like a specific value or like I took the lists, right, and like made a compiled list,
Mm-hmm.
but I'm trying to take like each, like say for MYC, like
Mm-hmm.
I'm trying to take the first value from each of those lists. But can you
Mm.
still, I guess, can you do that if I've compiled the list, like of the
By compiled,
samples?
do you mean like a nested list?
Yes.
So if you have um, something like this, I can never remember off the top of my head because nested lists are so complicated. But it should be
Mhm.
something like this. Like this will give you the first element of the first list.
Mm.
But there should be a way that you can get the first element of every nested list. And this is how I would solve that problem. Pull out first elements of every list Python nested list. I love Stack Overflow. So list comprehension is going to be the one that makes the most sense. So we know that each sublist or each item would be a list. So it could be like sublist index 0 for sublist in list. Does this make sense? Let's make these more useful variable names here.
And then if that was supposed to be the value from the dictionary, then I can just assign like um the MYC key equal or not equal, but like colon first elements.
Like dictionary key equals first elements. Like this.
Um
This is if you're trying to assign these first elements pulled out of these nested lists as the
mhm.
value of this key if you're trying to overwrite it. Um, Otherwise, you could also dot append or dot extend if it's
Would I
already
be
a
able to
list.
do would I be able to use something similar but like then grab like the second value for the second key and like they're on?
Yeah, you just
Or
write a for loop for that sort of thing. So it's basically this inside of a for loop. So it's all inside of something that's like for position in range key something something, like dictionary.keys in the range of the length of dictionary.keys.
Would
And
the
then
zip function also work for this?
there would be a way to make that work, but in general, the zip function can make things slower. It should be fine, especially for the task modules. They're not complicated, so you can definitely use it without issue. But if you're working with a data frame with a couple thousand rows, it would be really slow. But it's still, sometimes it's the best option, so sometimes it's still what you would use, even if it's slow. Okay. How are we feeling? So. Next week, it'll hopefully be more interesting. We're focusing on next week. Monday, we're reviewing the Pandas information, but then we're going over a literature review and just getting introduced to the context of the data that we're going to be working with. And then we're just opening that data file in VS Code in a Jupyter notebook, and we're not doing anything to it yet. Go ahead, Alicia.
Will we be posting the answers to module 2.1 and 2.2?
Yes.
Or is that like a Monday thing?
I can go ahead and post that today. I again encourage you to try to work on them by yourself first, just because I do think, unfortunately, the way we learn coding is through trial and error. But then, yeah, I'll post those so that if you choose to work over the weekend, which I don't expect of you, but if you choose to do that, you're not waiting on me basically to make progress. Any other questions?
so for next Monday, just module 2.1 is what you're expecting us to bring
Yeah.
or
Yeah, I
have
don't
done?
expect 2.2. I think 2.2 has some stuff that'll be a little bit irrelevant to what we'll actually end up doing. And I also, because it's like short time between now and Monday, I don't expect you to have 2.1 completely finished. But it's mostly just, again, getting exposed to these keywords is really important because these keywords are how we do troubleshooting well. And learning coding is really learning how to troubleshoot. So sorry that it's so not fun in the beginning. Hopefully next week it'll be more interesting, and it'll be more interesting when we're looking at real data as well. Okay. Then if that is everything, I will end this. I hope you guys have a good rest of your day. I hope you have a relaxing weekend. And I will see you on Monday. Bye.
Thank you. Have a good one.
Okay, Nori.